Hi, this is Professor Fernandez. This is video 1 in lesson 20. We're going to be talking here about solving exponential and logarithmic equations, and we'll do an example from Calculus Simplified to get comfortable with those concepts. Okay, so let's take a look at what the example says. So it says solve each equation for x, and it gives us actually 4 things to solve. I've kind of stricken out here C and D. We're going to do that in the next video. So instead, I'm going to focus on A and B. I've also written over here on the right-hand side, you can see some useful information that we're going to make use of. So the first example here, I'll zoom in a little bit, is 3 log x equals 1. So very first thing to say is that this is 3 times log of x equals 1. And the second thing to say is that what is log of x? So log of x is actually shorthand for log base 10 of x. So when you see log and there's nothing down here and you just see an x, then that is a convention that we're looking at a base 10 logarithm. A general logarithm looks like log base b of x, right? And that is a function. And the base here refers to what would be the base of an exponential function. I'll tell you what the connection is in a minute. But the base b has to be positive. Log base 0 is not a thing. Log base, -5 or something is not a thing. So this b has to be a positive number. Okay, so this is actually one of the 3 useful pieces of information that I have written down here for you. So log base x is shorthand for log base 10 of x. Okay, so now that we know that, let's go ahead and do piece by piece, use that information in the example. So I'm here and I can divide by 3 both sides, and I have log base 10 of x equals 1/3. Okay, so now the question is, how do I undo the logarithm, right? How do I solve for x? That's the point of this example, solve for x. So I'm going to use another useful piece of information, number 2 here. So log base b of c equals x. I can convert that to an exponential equation as follows. And I'm going to show you how to do this visually. It's kind of like a circular pattern thing. So b to the x equals c, right? Notice that that's exactly what this says. So for example, if I had log base 2 of 3 equals x, then what I would do is I would say this is the same as 2 to the x equals 3. So it implies 2 to the x equals 3. So I'm going to do a very similar thing over here. Let's apply it over here. So 10 to the 1/3 equals x. So this equation implies 10 to the 1/3 equals x. And you can see that literally tells us what x is, right? So x is the 3rd root of 10. And that is the exact answer. If you want a numerical approximation, this is about 2.15 or so. Okay, so that's the answer for part A. Now, there's a really nice connection, as you just saw, between a logarithm, right, and an exponential. So we're going to use that in part B. So to do that, first I'm going to declutter here and get rid of this since we finished that example. And then I'm going to go back and show you what this first fact is. It's really kind of the opposite story of the second fact that we just talked about. So let's talk about this fact real quick. If I have an exponential equation, b to the x equals c, I can convert this into a logarithmic equation using a very similar sort of reasoning. So I would say x equals log base b of c, right? That's what's over here. X equals log base b of c. In an example form, if I had a 2 to the x equals 7, then I would say, okay, x equals log base 2 of 7. So this would imply x equals log base 2 of 7. And there's a lot of nice information and insights that pops out of this sort of view. Notice that x literally is equal to a logarithm. And x is the same one that was here in the exponent. Therefore, grand conclusion, logarithms are the exponents in exponential equations. So that's a really nice insight. Logarithms are exponents. Okay, so with that first fact covered, let's go back. Oh, and I'll mention one quick thing. I actually separated these 2 facts because they're useful in different contexts. But notice that they really are, like I said earlier, just the opposite, in the opposite order. To convert from exponentials to logs, you do this to this. But then notice that this one is where this starts, right? Log base b of c, log base b of c equals x equals x. I've just written it a little differently. So if you want to start from a log, convert to exponential, this is your useful fact to use. If you want to start from an exponential, convert to a log, this is the useful fact to use. Okay, so I'm going to erase all that. Great. Undo for the iPad is awesome. And then go back over here to part B. So solve this equation for x. How would I do this? Well, actually, there are quite a few options here, and I'm going to do two separate ways to solve this, just to get you comfortable with a few different approaches and a few different concepts. The first one is kind of what we were just saying. So if I take this exponential equation, and instead I view it as 5 to the blah, right? Why did I choose Z? I just chose a random letter first one that came to mind. The point is to view this exponential equation as kind of like 5 to the x equals 7. But I don't want to put x there because that would be confusing, because this is 2x plus 3. How did it just suddenly become x? Okay, so I chose a different letter, Z. If this were where I started off with, then I could do exactly what I just did. I could say Z is log base 5 of 7. So this would imply that Z is log base 5 of 7. And notice that, that works just as well if I have a Z upstairs over here than if I do a 2x plus 3. So I could apply this same result up here. I could say 2x plus 3 equals log base 5 of 7. It's the same exact process. And as you go on in your practicing of these skills, you will be able to go from here to here without having to do this intermediate step, or you won't potentially get confused by changing the letters for the exponent. Okay, so now that we have that nice result, at this point, now this becomes an algebraic equation. Looks a little weird, but log base 5 of 7 is just a number, right? So that might as well be like, I don't know, 17. And you might as well be solving 2x plus 3 equals 17. At this point, you would do the same thing you would do if you were in an algebra class. So I'm going to solve for x here. I will subtract 3 from both sides, minus 3. I'll put the parentheses here just to remind you that these things go together. It's not like, log base 5 of 7 minus 3, for example. And then I will divide by 2, so I get log base 5 of 7 minus 3 divided by 2, and that's my x value. Great. If you were, again, to simplify this, or I should say approximate it, decimal approximation is about negative 0.89. All right, that's number 1. So I promised that I would show you a second way to solve this. So let's talk about number 2. So over here, let's talk about number 2. Okay, so 5 to the 2x plus 3 equals 7. What's another way that I could solve this? Well, I could work on the left-hand side instead of immediately converting it to what we did before. And what do I mean by working on the left-hand side? I could use all the rules of exponents. So rules of exponents. Okay, we covered that in an earlier video in this series. I want to say very early on, maybe video 1.3 perhaps, or 1 or 2.1. Can't remember the exact number, but check the earlier videos in this series and you'll see me talking in detail about the rules of exponents. Okay, so 5 to the 2x plus 3 is the same as 5 to the 2x times 5 to the 3. Because if we started here, we would have the same base, so we would add the exponents and get back to here. Great, so you can maybe see where I'm going with this. So now I've converted the equation to this. And then on the left-hand side, 5 to the third is 125. So this is 5 to the 2x times 125 equals 7. And then another rule of exponents, 5 to the 2x is 5 squared to the x. Because when I have something to the something, I multiply these two. So that would get me back here, right? So we also know that 5 squared is 25. So this is 25 to the x times 125 times 125 equals 7. Great. And at this point, notice that if I divide by 125, I am now back to an equation of the form b to the x equals c, right? b is 25, c is 7 over 125. So like we talked about over here, you can see it's still there from the first fact. We can solve this equation for x using that same sort of circular pattern. X is log base 25 of 7 over 125. So x is log base 25 of 7 over 125. Okay? This is literally the answer. You might be wondering, wait a minute, I thought this was the answer, okay? And this gets us into the next video, right? So video, let's see, where were we on? Video 20.2, talking about the rules of logarithms. Because the fact that these two are the same answer, yet they are so different, this looks very different from that, tells you that there should be some properties here that we should be able to use to either convert this over to that or vice versa. And indeed there are. Those are the rules of logarithms. We'll talk about that in the next video. But if I zoom out a little bit, if you're not told how to solve an exponential equation, right, these three useful pieces of information will come in handy regardless of which method you use. I would advocate for, as always, whatever makes the most sense to you. So if this first way of solving this equation made the most sense, it was indeed a little shorter, then go ahead, go with that. Or if you just, want to stick with these basic facts and kind of use them in this manner, so you get the equation down to here, you can do that. There are other things you might need to use, like the rules of exponents, but this is lesson 20 in the course, so hopefully by now you've had lots of practice with those. Okay, see you in the next video.